Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors in R2. So as per the problem, point A and B are points on the x and y axes respectively. So in part A, we have to find the coordinates of point P on the x-axis such that the magnitude of vector PA is equal to the magnitude of vector PB. So let's start with part A. So we are given that the magnitude of vector PA is equal to magnitude of vector PB. So the first step is to find vector PA and vector PB from the given points. So let's start with vector PA. So we can break down vector PA into its position vectors. So position vector OA is equal to the coordinates for point A, and OP is equal to the given point P. Now we can subtract these vectors. Now we can find the magnitude of vector PA. So we'll square the components, add them, and put the sum under the square root. Now 0 square is equal to 0 and the 0 will go away. And the square and the square root will cancel each other out. So magnitude of PA is equal to 5 minus A. Now we can find the magnitude for PB. So we'll start by finding vector PB. So we can break it down into its position vectors. So for position vector OB, we'll use the point B. Now we can subtract these vectors. Now we can find the magnitude of PB. So we square the components, add them, and put the sum under the square root. So this is the expression for magnitude of vector PB. Now as per part A, the magnitude of PA is equal to the magnitude of PB. So we can make an equation out of it. So this is the equation we have to solve to find the value of A and then we will know the coordinates of point P. So we should square both sides to get rid of the square root on the right side. So on the right side, the square root and the square will cancel each other out. Now we can simplify the left side by expanding the square, and for that we can write out 5 minus a twice. Now we can use FOIL on the left side to distribute the terms. So 5 times 5 is 25, and 5 times negative a is negative 5a, and then negative a times 5 is negative 5a, and negative a times negative a is positive a squared. Now we can combine like terms on the left side. So negative 5a minus 5a is equal to negative 10a. And we can subtract a squared from both sides. So the a squared terms get cancelled out. Now we can subtract 25 from both sides. So a equals 21 over 10. So point P is 21 over 10 comma 0. So this should be the final answer for part A. Now we can analyze part B. So find the coordinates of a point on the y-axis such that the magnitude of vector QB is equal to the magnitude of vector QA. So let's assume the point on the y-axis Q has coordinates 0, b. Since this point is on the y-axis, the x coordinate is equal to 0. Now we can find vector QB. So we can break it up into its position vectors. Now we can subtract these vectors. So we'll subtract the x components and the y components. So this is vector QB. Now we can find its magnitude. So we'll square the components, add them, and put the sum under the square root. So 0 square is equal to 0, and adding 0 won't change anything. And the square root and the square will cancel each other out. So this is the magnitude of vector QB. Now we can find vector QA and then its magnitude. So we'll break up into its position vectors. So for position vector OA, I use point A. Now we can subtract the vectors. Now we can find its magnitude. So we can square the components, add them and put the sum under the square root. So now we can move up or we can continue here. So 5 square is 25 and negative b square is b square. So this is the expression for magnitude of vector QA. Now we can set the expressions for magnitudes of QB and QA equal to each other and solve for B. So now we can square both sides to get rid of the square root. So on the right side, the square root and the square will cancel each other out. Now on the left side, we can expand the square by multiplying 2 minus b by itself. Now we can distribute the terms using the FOIL method. Now we can combine like terms on the left side. Now we can subtract b square from both sides. Now we can isolate b by subtracting 4 from both sides. So this is the value of b. So that means point Q is So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.